Okay, it's the moment we've all been waiting for, the unit circle. You should have this worksheet, and you should also have the large unit circle that you either started in Miss Irwin's class or picked up in Miss Butcher's class. So we're going to fill in the sides of this triangle so that we can find the coordinate of B. And this is a 30, 60, 90 triangle. I know this side is 1, so 1, root 3, 2. I have the side opposite the 30 is 1. I want the side opposite the 90. If I cross multiply, I'm going to get x equals 2. So this side is 2. I can also do that for the side opposite the 60. So in blue, I have the side opposite the 30. I need the side opposite the 60. I'm going to cross multiply, and x equals root 3. Now let's look at the 45-degree angle over here. I'm looking, let's finish that. The coordinate of B then would be 1 root 3 for the x coordinate and the movement on the y coordinate. Let's move over to 3, which is a 45, 45, 90, which is 1 to root 2. They give me the side opposite the 90 degree. I need the side opposite the 45. If I cross multiply, I'm going to get root 2x equals 4 root 6. Divide by root 2. I know that I can divide inside a paren. So I can divide 6 and 2 right here. So I will get 4 root 3. So side opposite, this is 4 root 3. This is also 4 root 3, which means that this ordered pair would be 4 root 3, 4 root 3. So I'm going to pause the video, fill in the rest of these coordinates. You go ahead and see if you can get the same answers. So now just check your answers. Okay, Kaylin, here is your M-A-R-K mark. Notice we have 30, 60, 90 degree triangles and 45, 45, 90 degree triangles. I'm going to pause at this point in the video, fill in the sides and the sine, cosine, and tangent. So it's beautiful when my radius is 1 because then the opposite over the hypotenuse is just the opposite because I'm dividing by 1. Tangent's a little different story, so it's the opposite over the adjacent. So I'm going to bring this up and multiply actually. So I'm going to rationalize and I'm going to end up with root 3 over 3. I'm going to pause and fill in the rest. So please check your answers. Thank you. So now let's just put this on a circle. And using your knowledge of special rights and a circle's radius, find the coordinates of B. So the radius is 1, which means from here to here is 1, which means opposite the 30 is going to be 1/2, which means opposite the 60, which is in there, is going to be root 3 over 2. This radius again is 1 because this point right here is 1, 0. Which means opposite the 30 is 1/2, opposite the 60 is root 3 over 2. This radius is 1. So opposite the 45 is root 2 over 2, opposite the other 45 is root 2 over 2. So the coordinates of B here are, I'm going to pause, are as indicated. What is the radius of all 3 circles? Well, like I just said, the radius is 1 unit. Unit circle will have a radius of 1 unit. When looking at the 7, 8, 9 answers to the 10, 11, 12 answers, it looks like my x value is my cosine and my y value is my sine. So we could write this as cosine theta, sine theta. Since we've used inductive reasoning to make our conjecture, we should see if we can find a counterexample. Reminder from geometry is an example that it doesn't work. For the following example, use the coordinates of B along with sine, cosine, and indicated. Okay. going to pause and fill in the coordinates. We know that the sine of A should be 1/2 and the cosine of A should be 3/2. Sine can't change based on what I just changed. So to fine tune this, your cosine theta sine theta will only work if the radius is 1. Wow, can't spell. So, how can we use an ordered pair on the unit circle to find the tangent of an angle on the unit circle? Well, if you remember back a couple minutes when I did the tangent with a radius of 1, it actually ends up just being the sine over the cosine, which is y over x. So tangent of theta equals y over x.
Hi guys, this is Hannah. I'm going to do a couple slides from your last video. So, okay, this is the unit circle, and we are going to start with the 30-degree angles. So right here, this is a 30 degree, and then you got to go to the second quadrant, third quadrant, and fourth quadrant to find all your other 30-degree angles. So then if you have this 30, you know that every radius from the center of the circle to any given point is going to be 1. And you know the angle, the side that is across from the 30-degree angle is always going to be half of this point. So that is going to be 1/2. And then you know this last angle right here is going to be 1/2 times root 3. So if you have 1/2 times root 3 over 1, it's going to end up being root 3 over 2. So it's root 3 over 2. And then this is your cosine value, always, it's the x value, so your x value is root 3 over 2, and your y value is 1/2. So now if you go into the next quadrant, this is going to be 30, this is going to be 1, and it's going to have the same coordinates except, you know, in the second quadrant, the x values are negative and the y values are still positive. So you're going to have 1/2 right here, because it's always 1/2 of the radius, and then you're going to have root 3 over 2. But because x coordinates are negative, you're going to have a negative root 3 over 2 and a positive 1/2. So right here you're going to put negative root 3 over 2, positive 1/2. And then you're going to go do the same thing in quadrant 3, and you're going to have 30, 1, and then 1/2 always, and negative root 3 over 2. And then because both x and y coordinates are negative in the third quadrant, it's going to be negative root 3 over 2, negative 1/2. And then so on, and you can figure it out in the fourth quadrant where only the y value is negative and the x coordinates are positive. So it's going to be a positive 1 right here. Oh crap, sorry. Positive 1 right here, and then a positive root 3 over 2. So your coordinate's going to be root 3 over 2, negative 1/2. So those are all your 30-degree angles on the unit circle. So now we're going to do all the 45-degree angles on the unit circle, which are going to be this one, this one, this one, and this one. And we all know that this is going to be 1, and this is going to be root 2 over 2 and root 2 over 2, like you learned in the previous slides. So what you're going to do is you're going to go put these up in your table or in your coordinates right here. And it's always going to be, make sure you rationalize the denominator, but it's going to come out as 1 over root 2. So if you just rationalize it, it comes to root 2 over 2. But then it's going to be 45 on all of these quadrants. And you're going to get, just because the x-coordinate is negative in the second quadrant, you're going to get negative root 2. Oops. Whatever. Root 2 over 2, negative root 2 over 2, positive root 2 over 2. And in this one, both are, so both are negative, and it's going to be negative root 2 over 2, negative root 2 over 2, and the same thing in the fourth quadrant, where it is root 2 over 2, negative root 2 over 2. And those are the 45-degree angles on the unit circle. Finally, we're going to do the 60-degree angles on the unit circle, which are these right here. They look like a butterfly. Anyways, okay, so if you have 60 degrees right here, you know this is always going to be 1, and it's the exact same thing as the 30-degree angles, except it's just in a different direction. So obviously this is 30, so half of that 1 right here, this will be a 1/2, and then this will be the root 3 over 2 like we showed 2 slides ago. So so your x-coordinate is always going to be this one, so it's going to be 1/2, and then your sine coordinate is root 3 over 2. And then you're going to go to the next quadrant, and it's going to be 1 root 3 over 2, 1/2. So the 1/2 is going to be negative because, because the x-coordinates are negative. So it's going to be negative 1 over 2, and then 3 root 2. And then the next quadrant, same thing, root 3 over 2, 1/2. And that's going to be both negative, so it'll be negative 1/2 and negative root 3 over 2. And then the next one will be 1 and then root 3 over 2. And it will be 1/2 negative root 3 over 2. So those are the last angle sets for the unit circle. Okay, so now we're going to look at radians on the unit circle, and I have no idea what y'all have all done, but these 4 are the easiest to remember, these 4 angles. And so we know the whole circle is 2 pi, so that's easy. And then this halfway across is going to be pi, because if a whole circle is 2 pi, then half a circle is going to be pi. And then if you were to divide that by 2 again, because we have half of the half circle right here, then it will be pi over 2, sorry. And then if you were to look at the next one down here, it would be 3 pi over 2. So now what I like to do is look at the 45-degree angles just by themselves, because they're the next easiest ones on the circle, which, so if you wanted to do that, if you were to divide pi over 2 by 2 to get this portion right here, it would be pi over 4, so, 4, whatever. Okay, so this is 1 pi over 4. This is going to be 2 pi over 4 because 1, 2 sections, 3 sections, 4 sections. So then you have 3 pi over 4, which is right here. And then 4 pi over 4, which equals pi. So if you want to keep going, you have 5, 6, 7, 8 sections on the pi. So you have 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is the same as 2 pi. Sorry about the bell. Then if you wanted to do the degrees of the pi over 4s, then you would get, either 360 or 0, depending on where you are on the circle, and then you would get 45, obviously, because it's a 45-degree angle. And then if you add another 45, because this is 45 right here, then you'd get 90. If you add another 45, you'd get 135. And then if you added another 45, you'd get 180. So those, and then if you keep going, you'd get 125. And then you'd get 225, sorry. And then if you kept adding, you'd get 315. And then if you add it again, you'd get 360. So there are your 45-degree angles, radians, and degrees. P.S. Shout out to Connor Kidd because he told me I had to.
So really quickly, I'm going to finish up the angles on the unit circle. So if you notice, the rest of these lines, we break our circle up into 6. Okay, we always include the quadrantals. So we break these into 6s. So this would be 1 pi over 6. This would be 2 pi over 6, which would simplify. The 90 would be 3 pi over 6. This would be 4 pi over 6. This would be 5 pi over 6. This would 180 would be 6 pi over 6. Then I would have 7 pi over 6, 8 pi over 6. 270 would be 9 pi over 6. The next would be 10 pi over 6. Then 11 pi over 6. And then I return back to 2 pi, 360. Those are my 30 and 60. So this would start off as 30, add 30 to the 90, add 30, add 30, and these are all degrees, add 30 to 180, add 30, add 30, add 30 to 270, add 30, add 30, and add 30. So at this point you should have a completely filled in unit circle. Last thing on that page I would like you to fill in is at the very top it says your coordinate x, y stands for, and then it has blank. I want you to fill in cosine theta, comma, sine theta. Yes, summer is coming. But please don't lose your heads yet. But when it does get here, I want you to make it a great story. Thank you so much for such a great year. In my 10 years, this has been the most fun I've had all year. Hope to see you next year.
Have a good summer.